Hey everybody, Mr. W here. Our topic today is something called input and output tables. Our focus today are input-output tables that involve a rule of multiplication. Let's get started. Find the rule and complete the table. If we take a quick look at our input-output table, you'll notice the top has the rule, but we don't know the rule for this particular one. And then we have two columns. We have a column on the left, which is our input column here, and then an output column on the right side that is right here. When you use an input-output table like this one, you would begin with your input. So for example, 5 would be in the first column, and we're starting with 5, which is our input, and the output would be 35. The next would be 3, and the output is 21. And the idea here is that for each of these numbers here, they're using a rule, and when the rule is applied, then you're getting your output number here. So the first thing we do when we are using an input-output table is that we look at our input and compare it to the output. And when I start with my first one, I see that I'm comparing 5 and 35, and it's more. And I can see that this is a pattern of more. So for the rule, I have to decide if it's going to be adding, subtracting, multiplying, or dividing. And if it's going to be more, which is in this case, it's either going to be addition or multiplication. My knowledge of multiplication, I can see that 5 times something equals 35. And I know that 5 times 7 5 times 7 equals 35. So I'm pretty sure that this is a multiplication rule. So how it works is that I would want to write an equation using my input and output. So for example, I'm going to start with my 5, and that is my input number. I said that I'm going to try multiplication. I said it's going to be 7, but when we start, usually we don't know that number. And then our output, we do know our output, which is 35. So our rule would involve this part here, the multiplication times what? Well, in this case, 5 times 7 equals 35. So I believe that our rule is a times 7. Once you have your rule, you would have to apply the same rule for all of these numbers. I'm going to check and make sure that this rule is true. So here, I'm going to write an equation, 3 times 7, which is my rule. And I know that 3 times 7 is equal to 21. So our rule is going to be times 7. For this one, it's going to be 9 times 7. And if you use your multiplication facts, that would be equal to 63. You can see here we do not have our first factor, so I could write this as blank times 7 because I do know the rule, and that is equal to 42. And I can use my knowledge of multiplication. For example, here I have 7. 7 times 6 is equal to 42. You can see if I go across it, that would be 6. So the missing number here would be 6. We talked about making decisions when you're doing input-output. The first thing you do is you compare the input and output. If the output is more, you add or multiply, which is really our focus for today. If your output is less, your two choices would be either subtract or divide. Steps are pretty easy. Our main goal is to find the rule. You can use a decision, I call it a decision flow chart or decision tree, and this is what I mean by the decision flow chart. You are comparing your input output and then making choices of what operation you're doing. Write your equations and use your knowledge of fact families, and then you solve for any missing numbers. Find the rule and complete the table. Notice that this input-output table is a little bit different. It's running from left to right. So really we have our input is on top and the output's on the bottom. Our first thing is that we want to find the rule, and to do that I have to make a series of decisions. I'm going to compare my first input with my output. And when I use my decision flowchart, when I compare, I see that when I start with 4 and go to 36, my output is more. So I've eliminated these. My choices are either to add or to multiply. When I'm looking at this and I see 4 and 36, it could be a rule of 32, but I know from multiplication that 4 times 9 is equal to 36. So I expect that this is probably a multiplication rule. However, I'm going to write an equation just to make sure, and then I'm going to check it twice with this. So to write my equation, I'm using the information here. I'm going to start with my 4. With my decision flowchart, I said I think it's going to be multiplication, and I think it's going to be a rule of times 9, and that would equal 36. So that checks out so far. So I think that my rule is going to be a times 9, but now I want to check it here. So I'm going to use my input, which is 8, times my rule of times 9. And I know that that does equal 72. I can just show that real quick right here. 8 times 9 is 72. So I now know that my rule is times 9. To solve this, I'm just going to go 6 times 9, and I know that that would equal 54. 3 times 9, that's my rule of times 9, that would equal 27. And you could use your multiplication chart. It's always good to memorize your facts. For here, I don't have my input, so I'm going to write this as blank. There's your blank. But then my rule times 9, and I do know what it equals. It equals 45. I can use my knowledge of multiplication here. I have 9. And if I multiply that by 5, so my missing number here would be 5. Okay, final exam. Find the rule and complete the table. Go ahead and pause if you like. See if you can solve that. Okay, I'm going to go ahead and solve. The first thing I want to do is find the rule, and to do that I have to use my decision flowchart. I'm going to compare my input and output. Here's my input. Here's my output, and I see here that my output is definitely more for each of my numbers here that I can see. So my choices are going to be either addition or multiplication. Well, if I added, it would be 4 plus 20. But I also know that 4 times 6 is equal to 24. So I suspect that this is a multiplication rule. So I'm going to write an equation to see if that's true. I'm going to use my input-output data. 4 times 6 equals 24. So I expect that my rule is multiplied by 6, but now I want to check it and see if that rule applies here as well. 6 times 6, and that does equal 36. So I have a rule of times 6. All right, 8 times 6 would be equal to 48. 10 times my rule of times 6. And here I do not have my first factor, so I can write this equation as blank times 6 because that's my rule. And I do know what my product is 72. I can use my knowledge of multiplication. I'm going to show you this on a multiplication chart. Here's 6. And if you look way down here, here's 72. So that would be 6 times 12. And so that would be the way to complete the table and define the rule. So in review, our topic today was input-output tables with our focus on multiplication. We discussed the features of a input-output table. And probably the most important thing is that you first have to compare your input with your output. If the output is more, which it is in this case, it's either going to be addition or multiplication. If the output is less, it would either be subtraction or division. As I said, then you simply write your equations to work and find your missing values. Then you use that rule to complete any missing numbers. Okay, hope that was helpful, everybody, and we'll see you next time.